Hi students, today we are going to see about the blow molding, rotational molding and transfer moldings in the plastic processing technology, which is in your 5th unit. So where first we will see about this blow molding, where this blow molding is used or applied. So you would have seen the water bottles, the big cans, which are made of these polymer materials, and here this is how they are manufacturing these type of bottles under the process called blow molding, where in the bottom you can see the a small nozzle where the gas will come, and this Parison in sense the molten like gel like a plastic material, the raw material which is used for making this water bottle is to be blown, with this gas which is inserted through this which is passed through this nozzle, and according to the shape of the surroundings this bottle will get blown up. So this is one of the best example where we can use this blow molding. To say what is blow molding, we have to explain the process. We have an extruder which produces a Parison continuously. So Parison is nothing but the molten gel or gel raw material of that particular product which we are going to make it. So two alternating molds are a number of molds in a rotary table. This rotary table, where we can call it as a carousel, capture a length of Parison where it is then blown into a hollow part. So the raw materials which we are using for this blow molding is polypropylene, polyethylene with terephthalate, and polyvinyl chloride. So these are some of the raw materials which we use for making the products under this blow molding. Under the types of blow molding, we have three different types. One is extrusion, another one is injection blow molding, and third one is stretch blow molding. So we will see one by one. So first, to explain this extrusion blow molding. Say you can see this schematic representation. From this we can easily understand how this extrusion blow molding is done to make a product. See, we have an extruder here which is attached with a die at its end. This die decides the actual size of the Parison. So Parison is nothing but a molten semi-solid gel-like form of the raw material. So this die will have those geometrical criteria. According to that, this Parison will be coming extruded from this extruder. And here we have four steps: Parison descents, inflating, and cooling, ejecting. So these are the four major steps which we follow under this extrusion blow molding. So first, what we have a mold. So this mold will be incorporated with the actual shape of the product what we need. So this Parison will enter in this mold, and this mold is closed, and it is set in such a way that the gas, when it is inflated inside this, and this Parison will bulge or expand, and it will form the layer on the surface of this cavity. So this, after taking this shape, so inside this the gas are inserted or inflated, and once the Parison is settled on the walls of this particular mold, then it is allowed to get cooled, and after cooling it can be ejected. So the final product would be obtained in the as shown in the fourth stage. Some important factors that we have to consider for extrusion blow molding are the polymer which we use for making the products should have viscosity and those viscosity should be appropriate for making the product at a high and low shear rates. then their melt strength, because this melt strength decides the uniformity in wall thickness. Therefore, no holes would be allowed to form on the once the product is getting cooled or the mold is getting cooled. And strain recovery, then crystallization rate. So there should be a slow rate of crystallization of the polymer is desired. And the thermal properties like thermal diffusivity, thermal conductivity, specific heat of these are the thermal properties of that particular raw material what we use. Then injection blow molding, a two-step process in which a preform is molded and kept in a near molten condition. There we are going for Parisian in the extrusion blow molding. Here we go for a preform. So if you see this diagram, in the first diagram, see the cover, the outer layer is nothing but the preform. So already it will be preformed into a basic shape. Then after that, this has to be molded inside, clamped inside the mold, and as we did in the extrusion blow molding, the gas is inflated inside this preform, and it is allowed to take the shape of that particular mold. After that, it can be cooled and ejected. The only difference between this injection blow molding and the extrusion molding is there the Parisian is formed by extruding from the extruder, whereas here basic shape of that particular gel or the raw material is already preformed, and then it is inserted in the gas nozzle, so that after that it can be allowed to expand and take the shape of this particular mold. So it is then indexed into another mold and blown into a finished product. And we have stretch and blow processing. Amorphous preform is molded and then heated to a temperature above its glass transition temperature. That is very important. So here this preform is heated to temperature above the glass transition temperature. This preform is stretched. That means that we have to elongate it by a push rod and then blown into a container. Some of the products like the bottles for soft drinks are produced from this PET using this process. Parisian programming can also be used to vary the wall thickness over the length of the part, or to maintain a uniform wall thickness for the complex part with the areas of high blow-up ratio. This is very important because the wall thickness should be uniform throughout. Suppose if you take a bottle, that bottle should have a uniform thickness throughout, where the holes or any other defects should not be present. So for which they have to maintain the areas of high blow-up ratio. And extrusion stretch blow molding. So this is also similar to that of your previous one, where this preform is inserted inside the die and the inflation is allowed to cast inside the die on this particular preform. Then we have to stretch. See, there is a provision to stretch this preform, and this preform is stretched up to this nozzle, gas nozzle. Then the inflation is allowed to take place, and after that, after this preform is blown up, we can get the shape of that particular the die or mold what we use. Then after cooling, it can be ejected outside. So final product would be obtained as it is shown in the final step. And injection orientation stretch blow molding. See here, you have already seen the injection molding. The same principle is used here to make the preform. That is, you have a hopper here. This hopper will be put up, will be allowed to take the raw material parts, and there would be a heater around this barrel, and this heater will melt this raw material so that it will slowly get into the screws of this particular injection arrangement. So there, once you turn this screw rod, it will inject the that is raw material, the molten raw material, and it will be allowed to take the shape of the mold what you have here. So this becomes the preform of that particular product, and this preform is again clamped, and it has to be stretched with some rod or some piston. Then the gas is allowed to flow inside this, so that it will take the shape of, it will cinch on the walls of this mold, so that it takes the shape of that mold, and finally the final product would be coming after ejection and the cooling and the ejection. So with this I am stopping this row molding, and we will see the rotation molding.